Hello everyone, welcome back to my channel Shraddha's Physics. This video is based on statistical mechanics for the core 14. So today we will discuss what is radiation pressure, and the first part will cover the normal incidence. So here the normal incidence means when the incident light falls on the surface in the perpendicular direction. So that is basically known as the normal incidence. Here the radiation possesses the properties of the light. So light means here you can say that is the photon of energy, or we will consider the velocity of light as c. Here the light exerts a small but definite pressure on the surface on which it is incident. Maxwell, on the basis of electromagnetic theory, he proved that this pressure is equal to the energy density for the normal incidence on a surface. It means that Maxwell explained that the total pressure will be equal to the energy density in case of the normal incidence. So here we are going to prove this P equal to U. So this radiation pressure, it is derived on the basis of quantum theory. Let us consider a photon of energy, that is h nu, it moves with a velocity of light c. So according to the theory of relativity, this photon corresponds to a mass. So because of the mass, its energy will be mass into c square, that is the velocity of light square, and this will be equal to, as we know, this is the photon and it has the energy h nu. So we can equate this to, that is mc square will be equal to h nu. From this relation we can calculate my m equal to h nu by c square. This m represents the mass of the photon. Now the momentum of the photon, that will be equal to mass into velocity. Mass into velocity will give the linear momentum. So here the mass is h nu by c square. Here mass equal to h nu by c square, and velocity means it travels with the velocity of light. So it means that h nu by c square into c, that will give h nu by c, which will be equal to this h nu. We can represent this h nu as E small e divided by c. This E represents the energy of the photon. Now we will see the momentum incident on the surface PQ per unit area per second. So that will be equal to this pressure equal to this momentum total pressure, that will be equal to sum over E by c. So that will be equal to sum over E divided by the velocity of light c. Here this sum over E small e, that will represents the total energy incident on the surface per unit area per second, that is equal to capital E. So this pressure will be equal to capital E by c. If this small u represents the energy density means the energy per unit volume, then the total energy passing through the area S of the surface, that is normal to the incident radiation. Here we are considering the normal incidence. So the incident light will be perpendicular to the surface. So that will be equal to density into the velocity of light into that area u c into s. Again this capital E, we know this is the total energy flux, that is the energy radiation per unit area per second. So we can write it as, this will be equal to this UCS divided by per unit area means that will be divided by S. So by cancelling S, that is surface area, so this E will be equal to U into C. Now if we will calculate this momentum, or you can say that this is the pressure, that is UC divided by C, so that will gives the U. So this P equal to U, it means that if all this momentum is absorbed, if all of this momentum is absorbed, it will give the rate of change of momentum per unit area. So this rate of change of momentum per unit area means this is the pressure of radiation. So here you can see that this pressure of radiation equal to this U, that is the energy density. So it means that for the normal incidence on the surface, this pressure of radiation will be equal to the energy density. So here that we have calculated, that is the momentum incident on the surface PQ per unit area per second. So this will gives the pressure. Here we have calculated the momentum of the photon, that is E by c, and here the momentum incident on the surface per unit area, that is E by c, and finally whenever I have calculated this pressure equal to, here we have substituted E equal to uc, and just simplifying we get P equal to u. So, it means that for the normal incidence on the surface, the pressure of the radiation will be equal to the energy density. Clear? So, this is all for today. In the next class, we will see the pressure of diffuse radiation. If you like the video, then you can give a like, share and subscribe my channel. Thank you.